All right, so welcome to our weekly chat session. And tonight our guest speaker is John Cochrane. So John's been flying gliders since 1972, and he soloed at 14. So he was one of those special people who got in early. After a brief detour to hang gliders while he was in college, he returned to gliders back in the late 80s. And he's been flying contests since 1990. He served as a contest rule committee member, and he's currently on the contest committee. He's currently the contest committee chair. John, is that the SSA contest committee?
Yeah, that's the SSA contest committee, and my job is herder of cats.
I bet it is. And he's written a good deal about soaring, which you can find on his webpage. John, you might want to shoot that out to the WhatsApp chat again, because I think it'd be a good idea for folks to go visit your webpage and see what you've got.
Sure. JohnHCochran.com.
Thank you. And in his day job, John's an economist. After 30 years at the University of Chicago, he came out to Stanford just 10 years ago. And he's been leading us in the skies as we chase him around the clouds ever since. And
I follow Rami and Kempton.
When I run out of eagles to find thermals for me up in the Sierra, I look for you. And you've bailed me out at least once. So thank you very much for that. John, you should be able to take over and start your presentation. Thank you.
I should warn you, never ever follow me, because I have a talent for finding rivers of sync that's unequaled in the gliding community. Here, can you see my...
We got you, yep.
I got an okay, I got a bunch of stuff. Trying to do the full screen view and not figuring out how to do it. No. Well, you can see the graph, right? It's like there. Are you seeing something that looks like slides? Oops, Dan, you're now muted.
Yeah, the full screen is down at the bottom right in presentation mode. I think that gets rid of...
Yeah, I don't use PowerPoint most of the time.
No, to the left of the Zoom bar is the first thing to the left of the Zoom bar, right there.
Oh, there we go. Great. I hope that looks better now. Okay, so let's go, and just feel free to jump in when if I'm not being clear. I have enough slides for 2 hours. I'm planning to do about half of them, but we don't have to do even that. So let's make it clear and jump in when there's anything isn't clear. So I thought I'd start with, what we want to do is go faster. That's the big issue, and we'll get to MacCready Theory. That's a small part of the go faster, but I thought I would give some broader thoughts on how to go faster. And there's the basic process is do what we're doing now, figure out what to do on the ground, and then practice it when you're in the air. So your job when you're just on sort of weekend flying is, have a goal, have things you're practicing, and try to make them automatic in the air. As I hang around on the grid at contests, pretty much everybody there is a complete world champion as far as the theory is concerned, but then we go in the air and it all falls apart. Now, there's a fair amount of, we'll do some theory and some graphs and some numbers, but no, the point is not to carry around tables of numbers in the cockpit and obsess about 47 knots versus 48 knots. Going through the theory, the point of it is really to get you a sense of what you want to try to do and get some rules of thumb that they're going to be useful in the air, but not to try to do a German fly by the numbers approach. So how do we fly faster? There are 3 rules of flying faster: climb better, and climb better. You thought this was good about MacCready Theory, but that's like number 5 on the list of how to fly faster. And number 1 is climb better. And I've been to a nationals or 2 every year since 1990, and always the guys who win are the ones who can magically pull a thermal out of their back pocket while the rest of us are floundering around. And that's really what it comes down to. So how do you climb better? First is just basic technique. And as I fly in a two-seater with many pilots, lots of pilots actually don't have that great basic technique of coordination and attitude control. So go out and work on your coordination and attitude control, especially in thermals where the gusts are bumping you all over the place. Is your airspeed just dead on all the time? Is the yaw string straight back all the time? It's not as easy as it looks. And one thing I've noticed is that many pilots, many pilots fly by feel, and you don't fly a glider by feel. You fly a glider by visual references. So you want the nose to be 2 inches below the horizon and just glued there, even though you'll be going through lift and sink. You don't want to let the lift and sink, let you go up and down like that. Similarly, there's a tendency to kind of roll into a turn and slip it a little bit and then pick up a lot of speed. And next thing you know, you're going 70 and then you pull back and so forth. You do that kind of thing, you're doing wild sort of ellipses all over the sky and you're going to miss the thermal. So just basic coordination and attitude control goes a long way, and concentrating on the visual of where is the nose relative to the horizon, is the bank angle steady, and so forth. Centering moves. It's important to center into the place where the lift is and not where the lift isn't. I won't do a whole long thing on centering moves, but think about your centering moves and are they actually being effective? Of course, what's lovely, gliding is the antithesis of instrument flying. Feel the force, Luke, turn off the instruments. Look outside. I think all of us spend way too much time staring inside. I learned this. I went to fly with G. Dale in New Zealand, and I thought I was pretty hot, and said, hey, how are you doing? He says, you don't look outside enough. Everything that you want is outside. That bird, the cue, the rest of it. But inside, you want to be not responding to the instruments. You want to be responding to the feel of the air, because that comes much sooner. And yeah, the good core is smooth. So lift isn't just, the whole game is the vario goes up. Can you distinguish, is this a gust or is this lift? And so the smoothness of the good thermal is one of the best indications. Of course, sometimes you got to work the ratty lift or else you're going to land out. But, when you can, you're sniffing around for that good, strong core. Climb better, climb better, climb better. 2, avoid bad lift. This seems obvious, but actually it's a really good principle. A lot of what I do is I try to have some sort of principles, little sayings that mull over and that I keep in mind to try to help make better decisions when I'm panicked in the air, which is usually. So weak lift hurts more than strong lift helps is a good principle to keep in mind for going faster. And I give an example here. What's the average of 2 knots and 10 knots? You might say 2 and 10, duh, 6. I know how to take an average of 2 and 10, but no, the answer is 3.5. Why? Suppose you climb 1,000 feet at 2 knots, that costs you 5 minutes. Climb 1,000 feet at 10 knots, that costs you 1 minute. So total, you've climbed 2,000 feet. In 6 minutes, you've climbed 3.3 knots. So the reason is what counts. Your average climb rate is minutes per foot, not feet per minute. And a 1 or 2 knot thermal is a disastrous number of minutes per foot, even though it doesn't seem so disastrous in terms of feet per minute. 2 4-knot thermals is better than a 2-knot thermal followed by a 10-knot thermal, even though, you want to, when you get that 10-knot thermal, you'll feel the itch to tell your buddies about it on the radio. So a lot of the strategy of what I follow is making sure you're never stuck in really weak lift. And if you don't get a boomer, that's not the end of the world, but avoiding the weak lift is really, really important. Strategy 3, leave bad lift. Say it again, leave bad lift. So one of the big strategies we'll think about is to always have a minimum acceptable climb in mind. What's the minimum that I'm willing to stop? Maybe it's 2 knots, maybe it's 3 knots. but there's a minimum climb rate. Well, once the averager is below that minimum climb rate, get the hell out now. And there's a strong tendency, oh, well, let's go looking around. It's here somewhere, it's here somewhere. No. Once the averager is below that climb, at least do something. Do not spend one more circle doing what you just did if the climb rate's less than that minimum amount. So
John.
what is that minimum amount? That depends on the situation. Dan.
Yeah, John, I think a valuable lesson I got from this point you're covering right here is that we look at our Vario and we say, oh my God, I'm in an 8-knot thermal, and you announce it on a radio to everybody, I'm in an 8-knot thermal. But when you go home and analyze, or you think about it and you're really looking at the averager, it's only a 3-knot thermal. It just happened to bounce to 8 and you got happy. But our actual average thermals are a lot smaller than we think they are.
Yeah, and there's a point I'll get you done. Well, even if you're flying perfectly, it takes some time to center into the thermal. Then you climb, even if you're climbing at 8 for a while, then it kind of peters off towards the top. And the average bottom to top might be 4 or 5, even if there was a lovely period of 8 in there. So when you think about, when we're thinking in a minute about MacCready speeds, it's about that total bottom to top, not that peak. Yep. So what is the real lift is important. But here we're just thinking about you got in a thermal, you're going around, it starts to peter off. What do you do if it kind of peters down to below your minimum acceptable level? Leave now. Don't keep trying to make it work. When you get into a thermal, unless you're desperate, yeah, I think a good technique most of us follow is you get in, you turn, you sniff, you sniff, you sniff. And what you want to feel is you go in, it's smooth, and the vario is still increasing as you turn. Because there's nothing anybody hates more than, oh, beep, 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 yes, that's wonderful. Let's go. Yeah, and you fall off the side and there's the sink. So, sometimes you're down low, you got to work around with it. But most of the time, you really want to, and the way to avoid that, and the way to avoid it is look for that situation where you're going in and climbing and it's smooth and increasing. If it drops off and you're still 45 degrees, bail out, turn left, and get out of there. I have a secret technique for finding and centering wonderful lift, and it's called leave bad lift and blunder into it. So often, the thermal just isn't up to snuff, or it kind of feels ratty or whatever. I say, oh, what the hell, I'll go on course. Off we go on course. And wouldn't you know, especially if you head off upwind, how often there it'll be. A couple of times I was thermaling with guys. I said, I saw you just roll out, and then, you made this huge thermaling turn and went right into the core. How did you know the core was there? I said, no, I didn't. I just bailed out and blundered into it. But if you stay in the bad lift, you'll never know. That's another little motto or saying I use: climb impatiently or climb greedily. You often start low and you're willing to take bad lift, but then you get halfway up, and like around in the Sierra, you might start at 3 or 4 knots, but by the time you're up to like 15,000 feet, you're out of trouble. If it's still 3 or 4 knots, get out and look for something better. And even though you're in what feels good, because often there's going to be a better core somewhere else under that cloud. And that's also both in Sierra and especially a little less in Sierra, but often in flatlands. Thermals are you've seen the donut model, the vortex ring. Well, think what happens if the thermal's a vortex ring. You'll typically go in the bottom of the thermal, get sucked up through the vortex ring and have great lift, and then it'll spit you out the top. But that can happen halfway up. So especially over flatland, you'll find yourself sometimes, if you get a little low, you'll do stepping stones rather than one bubble, go up and top and then sit with it in ratty bad stuff all the way to the top. Peel off and find the next one. And if you leave, you'll find your stepping stone your way back up to altitude. Now, this goes back to technique. The key for cross-country flying is to have confidence that if you see there's cues out there and it's not serious and dead, you see cues, you see signs of good things ahead, you see people ahead, you need to have the confidence that you won't miss the next thermal. And that's where decent thermaling technique is actually important before you go across country, because you need to know, if you go out there, you'll get it. And all this leaving bad lift stuff presumes that, you have a good chance of finding the next one. Some things not to do that we see all too often on traces, fishing for it. You get up, let's say you're in the Mendos, you get up, you're at 15,000, blah, blah, blah. You go back, you keep looking, no, go. If you're just looking and you've lost sort of the information of where the core is, you might as well go look on course. Stopping when you're very, very high is a common mistake. And all of this, there's a lot of sports psychology. That's a talk for another day, is the sports psychology of it. Trying to choose the emotion that will produce the good decision that you want to produce at the moment. That's what sports psychology is about. And a lot of that is sort of planning a pattern and so forth. So, one thing is look out and remind, yeah, there will be lift ahead. You will find it. And that takes, knowledge of the weather and some experience, but you can once you get that experience, you can put that in your head sooner. Another way of putting, why do people stop in thermal when they're too high? Well, they're scared. Well, why are you scared? You've gone say to Williams, you got up at Goat, you're at 11,000 feet, you head north, and then you stop at St. John's for another one, even though it's only 2 knots. Why? Well, I was scared. Really? How often have you actually landed out from 11,000 feet over St. John's headed north? Like almost never. So, how do you, is your fear justified in terms of actual landing out or difficulty? And often you say, oh no, I'm scared for no reason. Let's get going. So, okay, fine. I've given you my climb better because that really is far more important. But now we get to what I'm supposed to be talking to about today, which is MacCready theory. Cruising faster, making better strategic decisions, that MacCready theory, or which is just the theory of all gliding. People say there that, oh, MacCready theory doesn't work because of blah, blah, blah. No, if a theory doesn't work, you just need a better theory. And the generalized ideas of MacCready theory cover everything I've ever seen in how to make decisions in flying gliders. Okay, so here we're going to get to the math and the graphs. Get ready, guys. So 101 here is the polar diagram. Excuse me a second. I made these for an ASW 24 because I made them a while ago, but the same general principle applies. So as a reminder, on the X horizontal axis, you've got the airspeed. Vertical axis is vertical speed. The polar shows you the glider's sink rate as a function of its horizontal speed. And I hope you can see my little arrow here. If you're flying 60 knots here, there's your sink rate. Your achieved glide angle is demonstrated by that line from the origin to where you're speeding, or where you're flying, if that's the speed you're flying. Everyone okay? Polar, reminder 101. So now let's suppose you're climbing at 4 knots, and then you're gliding at 60 knots. I've got you gliding at 60 knots here. The average speed is where this line connecting the climb rate to the glide speed goes through the horizontal axis. Go see Appendix C if you're, that's easy to work out. I don't waste your time on geometry, but that helps you to see why we're doing what we're doing. So and there's your achieved gliding. The glide angle is vertical speed divided by horizontal speed. And the average speed is less than your glide speed because, of course, you have to climb. If we push that up, that would push the average speed forward. Climbing better always helps your speed. Climbing badly, you can see if I pulled that down, climbing badly would really kill my average speed quickly, right? And you can actually see here the point I made that pushing this up is going to help, but not enormously. Pulling that down is going to be disastrous to your speed because it intersects the x-axis over here quickly. So climb well and don't climb badly. So from that, so what's the best? What speed should you fly? Well, you want this average speed thing to be as far to the right as possible. So how do you do it? You push the gliding speed until this line here is tangent. So you get the classic MacCready diagram, which says the best average speed is when you start at the climb rate and go to the tangency point, and that gives you the classic MacCready speed to fly. All right, so that's how and thinking through that diagram, everything you can do is variations on that diagram. You move things around, right, left, and so forth. So how does this work? Another way of putting that, notice, here your best L over D was about 48. We're flying 80 at a MacCready Theory. So you're flying faster. You are achieving a worse glide angle. Where did glide angle go? I don't have the best glide angle set up here. The best glide angle is where it's tangent through zero. That's quite flat. Our glide angle is going to be quite a bit worse, but of course, you make it up in the thermal ahead. So another way of putting this, I'm an economist. Everything is buying and selling, and all of gliding is trading altitude for time. We have altitude, we want to turn it into time to get, because we want to go somewhere fast, right? The objective today was getting there faster. So if I had more altitude, I could get there quicker. And on the other hand, spend the altitude you got to get there as quickly as possible. That's it. Everything is the trade-off of altitude for time to finish the course. So the principle that, this MacCready diagram, another way of explaining it is that in order to do as well as possible, you should sell your altitude in cruise at the same rate that you buy altitude in climb. In climb, you stop. You lose time, but you gain altitude. So in cruise, you also, by cruising faster or slower, you can get extra time. You can lower the time by losing more altitude. So you should do those two things at the same rate. So buy and sell at the same price. And the classic way of putting that was, the climb ahead, 4 knots ahead, so you glide, you glide at the speed where gliding any faster or any slower trades extra altitude for time at 400 feet per minute. Of course, the problem with that is nobody knows what the next thermal ahead is, right? So now what? You got to guess. Well, I think the modern reinterpretation of that is yes, you do. So at any moment in time, think about your level of confidence. What is the minimal thermal you would accept right now? Remember that we had that concept, the minimum thermal strength you would stop in thermal in. Well, the minimum thermal strength you would stop in thermal in, that means you are willing to buy altitude at, say, 2 knots. So you should sell altitude at 2 knots. So actually, you do know. You have to just decide at any moment what's the minimum thermal I'd stop in, and then set that at your MacCready, and then keep going, and then stop in that thermal. And of course, it's going to be the next thermal. And of course, that's going to change over time. As you get lower, you're going to be willing to stop in a weaker thermal, so you'll glide slower. As you get higher, opposite, you'll glide faster and also be more choosy, insist on taking more thermals. So it's just a consistency condition. Don't wait for real boomers and fly really slow between them. That's dumb because you're able to buy altitude at a cheap price. So why don't you sell it at the same price, for example? So this is quantitatively for the ASW24. And you can see I chose it in part because it's not a fancy glider, but it's typical of what you start with when you're in this business. Best L over D is 48 knots. If you're going to climb 4 knots, pretty reasonable around here, you're going to be cruising at 83, and that's dry. Add another 5 to 10 if you're wet. So get used to flying a lot faster than you may have in your early years. 80. Now, standard class, there's an issue that there's a separation on the bottom surface, which cuts in. There's actually a kink in the polar for most standard class gliders. You got to know where the kink in the polar is. And basically, speed to fly in a standard class glider is 2 knots below the kink in the polar, and I don't care what the lift is. But 15-meter gliders that have a smoother thing like this, then it's more of an issue. Here's some numbers for the ASW24. And you should know, you don't need to do, I've written computer programs and gone crazy about this. You should know, though, the MacCready 1, 2, 3, 4, 5 speeds for your glider, dry and wet. Not exact, but you should kind of have a general idea where they are. And they're not that different for classes of gliders. ASW24 discus is all the same. Ventus, ASW27 is all the same, and so forth. So here's how I think of them, and I think in terms of MacCready values, and then translate that to speed. So MacCready 1, I would stop and take a 1-knot thermal. That's desperate. So MacCready 0, never. You always want to, well, you have to be unbelievably desperate. MacCready 1, because look, you go, as you go from MacCready 0 to MacCready 1, you're going 10 knots faster, and that's a huge difference in speed. So you would go, that's real desperation. MacCready 2 is kind of a normal cautious range, flying 68. MacCready 3 is a good setting for a good everyday setting. We're not really in a race, but we kind of want to go, and we're confident about things. I would advocate, set MacCready 2 to 3 most of the time, especially in the mountains. Your altitude band is not as big as you think, so you don't want to go ripping along in the mountains. MacCready 4 is kind of a good setting for you're ripping along on a fine day. Even when you're climbing in 5 and 6 knots, we'll get there in a minute. MacCready 4 or 5 is good enough for gliding. And notice in ASW24 you're going 83 knots. Now I think in terms of MacCready value, partly because then as you jump to different gliders, the same day you're going to be flying MacCready 3 in everything from a 126 to an EV29. It's just going to be different knots. But once you think in terms of MacCready, you can jump from one glider to another easily. This is deeper numbers. I just want you to look at the ones in red just to, get a sense for different gliders. A standard Cirrus, at 51 is best glide. 70-ish is a 70-ish is a typical glide speed. As you move up to an ASW27, notice 80 to 90 is a typical glide speed. So flaps really open up that high speed range. And a wet ASW27, 100 knots is a typical glide speed. And once you get up to an AS33 or a Yonkers, these guys are bombing around at 110 knots. Well, that's the MacCready 3 to 4 speed. Go for it. So modern gliders really have opened up a dramatically high speed ability without too much loss. This is, the ASG 29 is even better, 95 to 100 and 103 wet. Wet makes a big difference over dry. And if you look at nationals traces, that's what people are doing, and they're not being crazy. That only needs 3 to 4 knot thermals to make that worthwhile. Now, another well-known fact is that don't obsess about this. Now, let's talk about practically how to use this. This is the plot of, if you're 5 or even 5 knots too fast or too low, the difference in your average speed is very small. So, don't obsess about 4 knots versus 5 knots, and don't obsess about the speed too much when you're doing it. Flying a lot slow is really painful. So flying 0 or 1 will hurt a lot. Flying 5 knots too fast or too slow doesn't make a lot of difference at all. Of course, MacCready, you've seen the diagram. I'm just kind of going over and think about how do we do this in practice. To fly faster in sync, you fly lower and left. Duh. And the diagram tells you how much you fly faster in sync and lower and left. And that's worth, a table of MacCready values is worth kind of thinking about in your head on where you go. And in this case, for example, we were going 80 in our 4 knots. If you're in 2 knots of lift, you want to slow that down to 60. If you're in 2 knots of sync, you want to speed up to 100 to get out of the sync. So you got to slow now. Now the diagram already tells you something. Many of us, when we're in 2 knots of lift, might be tempted to really slow down and milk it. And the diagrams don't do that. Don't get too slow in lift. It says in 2 knots of lift, you only want to slow down to 60 knots. You don't want to slow down to 0. Likewise, do speed up, but get a sense of how much or how little. So let's make away from theory. Let's talk about how do we do that in practice. Do not chase the vario. I think everyone's told you that, but the reason is, of course, you'll be late. None of us is good enough to do the timing The air goes blah, 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 blah. You push forward. The minute you get it up to speed, which takes, a couple seconds, it's already, then you pull way back. And the minute you get it down to 40, you're back in the sink again. So typically, this is why you should know the MacCready numbers roughly for your glider, or have an instrument that'll tell you, in a MacCready 3, my basic cruise speed is 90. So you kind of center on 90. And then if you know you're in persistent sync, if you know that 5 seconds from now it's still going to be sync, you really want to start speeding up. Going through wave or some downflush or something. Similarly, you don't pull back at every beep, 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 pull back. No, no, no. You don't want to try every zoom because you want to set you have to decide now what speed you want to be 5 seconds from now. And the beep beep of right now is going to be gone 5 seconds. So when do you pull back? Well, when it's big, when it's smooth, when there's some gorgeous cloud laid out in front of you, you can kind of see the convergence pattern of the cloud. Yeah, now slow the hell down because 5 seconds from now that it'll be good. Changes matter a lot. So I listen a lot to my Vario, not so much for what it tells me to do, but for the change in tone. It's going boo 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 boo, and then it starts boo 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 boo. A little bit less sync means aha, we can start gently easing because it looks like we're heading into lift. Big zoomies and pushovers. First of all, they're inefficient. You lose a lot of induced drag when you do it. The second thing is be wary if you're with other gliders at all. If you're with a group of gliders and you do a big pull, it's going to be really exciting because you can't see him and he can't see you. And if you're lucky, the flarm will go off like crazy, but you still don't know where it is. So be really careful about too big zoomies. It is okay if it's very strong persistent lift, under those big clouds out in the Sierra, pull it down to 40 knots and pull the thermal flats and just go straight. You want to park it if possible, but be ready to push. There's a big, I suffer this a lot, a tendency of being in the lift goes, beep, 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 it starts weakening and I'm sitting there holding back saying, oh, no, I want more, I want more, I want more. No. Because being still slow while it's in sync, that's very inefficient. It's better to be too fast than too slow in Dolphin flying. Yeah, there it is. Don't be too slow wishing for it. Leave thermals gently, following clouds, winds, and gliders. You may have read these, George Moffat says you take a Chandelle 180 and bomb through the core and go. No, that's 1970s technique. Once we got good total energy netto varios, we found out that's a terrible idea because surrounding any good core, there's often lots of good lift. So a good way to leave is, and also, by the way, that's dangerous as hell if there's other gliders around. Just roll out on course, and maybe upwind. What you want to do is milk that lift that's not good enough to circle in, but you want to milk it. And maybe actually the next great core is there too. So go slowly upwind, following the clouds, and then speed up as it looks like things are ending. Of course, course deviations. There's a whole theory of course deviations. It's the MacCready theory. Obviously, deviate if the increase in time is worth the increase in altitude, and if thermals are really strong, you don't make as big deviations. If thermals are weak, deviations are better. But look up your table of cosines, which is how much you lose by deviating. 20 degrees is 6% longer. 30 degrees is 13% longer. 20 to 30 degrees deviation is often quite worth it. The one thing you want to make sure not to do is if you decide to make a deviation that's 45 degrees off course, then you feel bad about it. You go kind of halfway. No, if you're going to go to that cloud, go to that cloud and just do it. And a beginner mistake is never cruise at best LVD. Never. Even if you're totally desperate. If you're not in lift, you're in sync. And if you're in sync, you're in at least 1 knot sync, and you want to be flying the 1 knot MacCready speed. So you never fly that slowly unless you're absolutely desperate and you're in smooth air with no sync whatsoever. So get going on that faster. I don't care what glider. Almost all gliders minimum 70 knots, yeah, and lots more. Let's talk about the instruments to make all this work. A fast, well-compensated speed to fly audio is essential. And speed to fly means I really like it. I advocate and like it set to telling you in cruise push-pull sounds. Not because you're going to follow the push-pull, but because you want to feel the air and target your decisions relative to the correct speed. And I'll tell you why in a second. But well compensated. If you've never done it, Williams is wonderful this because you get long final glides in totally calm air. So when you're coming off and sitting there, gliding in from 8,000 feet with nothing to do, try the compensation maneuver, which is you go up to like 90, 95 knots, stabilize it, get the speed stabilized, make a gentle pull-up. You will notice that as you make a gentle pull-up, the G's will cause the vario to indicate down because the glider is being less efficient. And then go up at 30 degrees, hold the 30-degree attitude constant with 1G, and watch the vario. Now, when you think about it, this is an extreme test because if you're going 100 knots and you're going up 30 degrees, you're going up at 50 knots. So that's a lot. If it's only showing 2 to 3 knots of up or down, then it's very well compensated. All of our varios, there's an electronic adjustment, and so get the compensation good. Don't blindly follow the push and pull. What you're doing the speed to fly is listening to the air. Are we going into lift? Are we going into sink? So listening for those changes and thinking about speeding up, slowing down gently and smoothly, or maybe deviating to the side. No, that's okay. I don't advocate like having a netto to look at, especially in wave. But if you set your audio to netto, what it leads you to do is milking bad lift. It leads you to, when you're in 2 knots of lift, it leads you saying, yeah, when you should be slowing down to 60, but not to 40. Netto is the same as speed to fly with MacCready Zero, but you don't want MacCready Zero. And of course, if just setting a regular vario while you're in cruise, it's next to impossible to do the right thing. Because when you're bombing along, if you get into 2 knots of lift, you're still going down. You're going down 3 knots instead of going down 6 knots, and you should be slowing up. But the vario is still down 3, down 3. So netto tells you too optimistic, and regular tells you too pessimistic. Put it on speed to fly, and just don't listen to it. Don't push and pull too much. Just use that to tell you what the air is doing, because that's what you want to know is what's the air around me doing. So that's how my vario is set up. In cruise, I have a very fast speed to fly audio and no deadband. Lots of people like deadband, and I don't know why. I want to know at all times what's the air doing and how is it changing. And bad, which it usually is when I'm flying. But when the sink is dropping off, I want to know that the sink is dropping off. I like the needle to be on relative, so I can know if I were to stop here, how fast would it be climbing. The averager, you want the averager to be a slow netto in cruise, but you don't really use it that much. In climb, you want the audio to be very fast, regular TE, and again, you kind of want to mentally do the filtering, and you want a good averager because that tells you when do I get in and out. If you can, it's nice to disconnect the MacCready setting from the computer to the vario so that you can calculate glides on one setting and listen to another setting. And I'll show you that in just a minute. And by the way, some varios, which are otherwise great, I really hated my older LX vario because it had awful speed to fly up. It should, when you get into 2 knots of lift, it should make the same noise in speed to flying mode as it does in other modes. And some of them, it tells you to respond much more to speed than to lift, which is too bad. But anyway, let's move on to using creative uses here for the MacCready setting on the glider. And one is safety glides. How do you use it for safety glides? you can kind of tell if you're flying along at MacCready 2, the computer tells you how far you're going to get. But that's kind of if you're gliding over Lake Tahoe to get back to Truckee and you're on a MacCready 1 to MacCready 2 glide, this is not a good idea because things might go wrong. So how can you use it to help you make those answers? And the answer is pretty simple. You want to use much higher MacCready settings to calculate the glide, but then you don't want to fly that bomb out MacCready setting. You want to fly a much lower speed to set yourself a conservative glide. So some guys do, well, I want 25 to 1 or 20 to 1. Well, that's good. That's a safety procedure. But the problem is 20 to 1 doesn't compensate for what glider. It doesn't compensate for wind and that sort of thing. And so being able to use the computer is kind of handy to make those decisions. So this rather too complicated graph. How does the glide computer work? A glide computer will look at how far away am I from the airport. And, suppose in my example, I'm at MacCready 4 and it says 0 altitude MacCready 4. What is it doing? It's saying, well, if you set MacCready 4 and if you fly MacCready 4 in still air, you will fly this glide angle, and that glide angle will just get you to the airport, compensating for altitude and wind and so forth. So that is a nice way. Now, what you can do is the MacCready 4 would tell you to fly this fast. What you want to do is compute that angle, but you don't want to fly that fast in order to, because you want the safety of that angle. So if you input MacCready 4, then you'll get a fairly reliable computation of a glide over a angle. But of course, you want to fly slower because the whole point is you want to do it in safety. So here's an example. I just put some numbers together for our friend the ASW24. Suppose we wanted, if you want to, for example, say I want a 24 to 1 safety glide to fly over Lake Tahoe. Well, that would be MacCready 5. Now then MacCready 5 gives you 24 to 1. Now you want to, of course, fly that at MacCready 1 because what you're worried about is the worst case. The advice to fly 90 knots says that you're going to average lift and sink. The problem is if you average lift, great, you'll climb up and do well. If you average sink, you're going to learn how to swim. And you don't want to learn how to swim. You want to ask the computer a different question. And for example, I here computed what glide angle do you achieve if you're in 1 knot sink. You achieve 24. So if you want to allow for the possibility of 1 knot sink all the way from the shores of Lake Tahoe to Truckee, then what you want to do is input MacCready 5, but fly it as if you're MacCready 1. And there it's handy to be able to switch back and forth, to have the Vario tell you fly MacCready 1 and the glide computer to say, give me MacCready 4. Now you can't do that on a lot of computers like LXs, but you can switch back and forth. So switch up the MacCready to 5 to see, am I on a good glide? Then switch it back to 1 to tell you to, not fly too fast. And that's a good way to do it. These are very high MacCready settings. Sometimes if your life depends on it, you might want to have a 20 to 1 glide angle. Well, that's a MacCready 7. So our gliders are so efficient that in order to fool them into telling us that kind of safety glides, you have to put in a pretty high number. Rules of thumb that I use are for my safety glides, 30 to MacCready 3 is what I'll typically use to final glide. MacCready 4 to 5 is good for every day. If it doesn't work, I'm not going to kill myself, but it's kind of inconvenient. MacCready 5, 6, 7 if you're if there's really very few options. And more, of course, if your life depends on it. So another couple of hints on this guy. First, longer glides are safer than shorter glides because sync doesn't last forever. If you flip a coin 10 times, you're not likely to get 10 tails in a row. But over the next 5 miles, you might get 2 tails in a row. So you can use a lower MacCready setting and a more aggressive glide if it's a longer glide. For you math geeks out here, the 6 sigma safety height, the safety height you need is the square root of the distance, meaning you need to be steeper if you're close and farther away. And that's why we do a glide angle plus an arrival height. A glide angle and an arrival height is an approximation to the square root formula, which is the maintain a 6 standard deviation chance of killing yourself. The only special case is no lift, no sink. You can do MacCready 1 glides at Williams, because with no lift, there's no sink. And I didn't. Stronger conditions are more dangerous. You need to have a bigger margin in stronger conditions. Why is that? If there's absolutely no lift, there's absolutely no sink. So you can do you can confidently do a MacCready 1 or MacCready 2 glide because you know there won't be sink. If there's booming thermals, there's also booming sink. Now, if you find the thermal, you're going to stop and climb in it. The case that you want to guard against is that you don't find the thermal and it's just sink all the way. So you got to be more careful in booming conditions. That's usually a surprise.
John, we've got one question in
Yes,
the chat.
please. Oh, I wasn't watching the chat.
Yeah, so in the chat, Rami's asking, why would you fly MacCready 1 and not MacCready 0 in your example of milk and glide over the lake back to trucking? And he's talking about clearing terrain or making the airport as a concern.
Yeah. The problem with MacCready 0 is that if there's any buoyancy to the air, you're typically in sync. So I would set, this is actually a case where I might, if I'm worried about clearing the terrain, I would set the MacCready to 0, but my block speed would not be centered around the MacCready 0 speed because you're almost always in like half a knot or 1 knot of netto sync if you're not in lift. So
yeah, but the flight computer, John, the flight computer already corrected for seats.
Yeah.
So the MacCready, when I say MacCready 0, I don't mean MacCready 0 speed at no sync, but MacCready 0 at your flight computer, the sync will automatically tell you to fly faster anyway.
Yes.
So if you do MacCready 1, you basically add a few more knots to the speed. So
no, thank you. That's exactly right. Now, if you're really worried about your life to the point that you're flying MacCready 0, maybe you should turn around and go land at Carson City. But because usually, if there's still any speed interest at all, going up from MacCready 0 to MacCready 1 will buy you 10 knots of cross-country average speed at very little cost in altitude. But if you're worried about your skin, MacCready 0, but then mentally be prepared that you'll probably be in sync. So don't think I'm going to fly the best L over D speed of my glider. You're probably going to end up flying the MacCready 1 speed in still air, but you're exactly right on that.
Just to clarify, you still, even if there is sync and you set to MacCready 0, you're still flying in MacCready 0.
Yes.
But your speed is higher than the MacCready 0 because of the sync. But I still call it MacCready 0 because that's what the setting is.
Yes.
Correct?
The setting is MacCready 0, but you will be flying.
Yes.
The MacCready 1 still air speed is the MacCready 0 1 knot sync speed.
Right.
So whatever way you want to think about that, yeah, you'll be flying 70 knots, not 48.
Right. But my concern, if people just already starting with MacCready 1 or 2, and obviously flying faster because of sync, they may actually be flying in reduced glide and potentially not clearing terrain.
Absolutely.
Or marginal, or making the whole glide. My point is, it may potentially make the whole glide more marginal than MacCready 0. Still, MacCready 0 using still sync and lift, obviously, but it just makes the whole glide more marginal just to get in your oil COE glide maybe half a kilometer per hour faster on your average speed. But you're just getting a more marginal glide. So I personally, on my all final glides, and it's not just Truckee, but Hollister, Williams, whenever I do it from far away, I'm on MacCready 0. So later, of course, I speed up since I'm most likely going to start gaining on altitude. But I'm starting with MacCready 0 when it shows me that I have just pattern. When my MacCready 4 showing me that I have just pattern for the airport, and I'm starting on final glide, my flight computer is on MacCready 0.
No, you're typically doing that at 7 p.m. and you're flying OLC and it's over Lake Tahoe. In which case, I completely agree with your philosophy. Often, though, if you're flying a contest, you're coming in usually over halfway decent terrain. It's 4:30 p.m. and a little bit of extra speed is important. And there, if you start there, actually, most contests, the final glide is a crucial part of that extra half a knot over the other guy. So what you really want to do there is keep climbing until you're at a MacCready 4 glide and then fly it at MacCready 4, where your safety is the ability to slow down later or take a weak climb or even land out in a pasture, which is a very different circumstance.
Yeah, contest is a completely different use case. I'm talking about cross country, not contest. I know contest is a whole different ball game.
I just want to say one more thing because we're running out of time here, which is this calculation. Now, the classic MacCready theory ignores the fact that there's the cold hard ground down there. And so I asked myself, what should you do? This is a day, I calibrated to a day when there are mostly 4-knot thermals and some 6-knot thermals around, but it's over flat land, but you might miss thermals and then you might land out. And landing out, I put in the cost of landing out at US contests and figured out what you should you do. And this graph gives you a graph that tells you pretty much how people fly. Most of the thermals are 4 knots. There's a couple 6-knotters. There's a couple 1 or 2-knotters. So what do? Your MacCready setting, the weakest thermal you take and the speed you fly. When you are up at 5,000 feet, yeah, it's pretty close to MacCready 4. As you get lower, though, you steadily become willing to take weaker lift, and you fly slower to get the more range to fly that weaker lift. And this is a smooth thing. This is pretty much how people fly in the flatlands. Whoops, wrong one. MacCready 1 at 1,000 feet or even less. I think I overdid it here with the chance of making a save. MacCready 0 at 1,000 feet. 2,000 feet, you can go up to MacCready 2, 3,000 feet, MacCready 3. And this will naturally, you follow this, you'll naturally fall into a height band. As you're high up, you'll be really choosy, flying fast. I'm not stopping for anything. As you get lower, you're willing to stop more. But then as you climb up, you bail out and look for something better. Something I didn't say, and one last thing I didn't say enough about was, where did it go? The lift that counts is the lesser of the initial and the total climb. So let's say you glide, it takes a minute to center, you climb at 3 knots, 4 knots, 5 knots, 6 knots. Oh, darn. Oh, good, I found it again, 7 knots. You call your buddies and I got a 7-knot thermal over here. Peters out to 4 knots and then you go. As far as the glide MacCready setting, what does that count as? Not 7 knots. It counts as a 3-ish knot thermal, if that's the initial and final climb, or if the total bottom to top was 4 knots. That's the opportunity that you're thinking of when you glide. So that's one of the reasons that we only glide typically with the MacCready setting set to 3 or 4, even when the best thermals of the day peak out at 7 knots, because the actual opportunity to climb, including centering time and its lower up and down, is less than that. It also says it's okay to stay in if it was 6 and 7 knots and it slows down to a smooth 4 to 5 knots, it's okay, because the bottom top, as long as you're climbing faster than the bottom to top average, it's okay to stay a little while, no matter what they say. I think that's where I'm going to stop. There's a lot more to do here, and I just want to advertise. There's the PhD of MacCready. There is, and then the postdoc, How do you handle upwind and downwind turn points? Yes, MacCready operates in wave just like anything else, but it's different. What's the optimal way to glide to a ridge? How many course deviations? The fast gaggle, what's the right way to do final glides? And of course, the trade-off always matters what you're trying to do. If you're ramming and you want distance, you do one thing. If you want to set a record and flying any less than 150 kph is a waste of a day, then you're going to push a whole lot harder than you do otherwise. So I'll just leave that for next time. Let's go talk about the weather for today.
Thanks, John.
Unless there's
Before we
questions.
jump into weather, let's throw it out for a few questions.
Well, I expect to see some good speeds this weekend.
I expect that too. All right. Well, thanks again, John. Really, really great presentation. Always good to hear it.